December 19th, 1941. 2:47 a.m., Alexandria Harbour, Egypt. Lieutenant Luigi Durand de la Penne lies motionless in 4 feet of water beneath HMS Queen Elizabeth, his breathing apparatus hissing rhythmically in the darkness. Above him, 33,000 tons of British battleship rock gently at anchor. His hands grip the mine's magnetic clamp as he positions it against the hull. The charge contains 485 pounds of TNT, enough to break the battleship's spine. He has 16 minutes before the delayed fuse activates, 16 minutes to swim clear of the harbour before the Mediterranean Fleet's flagship explodes. His partner, Chief Diver Emilio Bianchi, signals from 15 feet away that the second charge is secured. They have rehearsed this moment hundreds of times in La Spezia's training facilities, practicing until they could assemble and place charges in complete darkness by touch alone. But rehearsals occurred in calm water, without enemy destroyers prowling overhead. De la Penne checks his wrist compass one final time. The luminous dial shows 2:51 a.m. The explosions are timed for 6:10 a.m., synchronized with identical attacks on 5 other British warships anchored in Alexandria's inner harbour. What the British sentries patrolling Queen Elizabeth's deck cannot know is that the men planting explosives beneath them represent 3 years of secret Italian engineering, a weapon system so unconventional that British intelligence dismissed early reports as propaganda. These underwater raiders, officially designated Siluro a lenta corsa, slow-running torpedo, ride modified torpedoes through enemy harbours to deliver charges that will sink more British tonnage in 6 hours than Luftwaffe bombers accomplished in 18 months of Mediterranean operations. The technology beneath HMS Queen Elizabeth combines human courage with precision engineering in ways that will reshape special operations warfare for the next 8 decades. Yet at this moment, crouched in the darkness beneath the Mediterranean Fleet's flagship, de la Penne knows only that his oxygen supply is running low and British depth charges are exploding in the outer harbour as security patrols search for intruders. The story of how Italian frogmen reached this moment, poised to cripple Britain's Mediterranean naval power, begins not in wartime desperation, but in careful pre-war planning that anticipated the exact scenario now unfolding. The origins trace to 1935, when Italian naval engineers began developing unconventional weapons to counter British naval superiority in the Mediterranean. The mathematical reality was stark. Britain's Mediterranean fleet displaced 326,000 tons across 3 battleships, 4 aircraft carriers, and 15 cruisers. Italy's Regia Marina, while numerically impressive on paper, faced operational constraints that negated its apparent strength. British possession of Gibraltar, Malta, and Alexandria created choke points that allowed smaller British forces to dominate sea lanes essential to Italian logistics. Traditional naval engagement favoured the British through superior radar, better fire control systems, and operational experience accumulated across decades of global deployment. Italian planners recognised they could not win a conventional fleet engagement, so they chose not to fight one. The concept of human-guided torpedoes emerged from Italy's tradition of unconventional naval warfare dating to World War I. On November 1st, 1918, 2 Italian naval officers, Raffaele Rossetti and Raffaele Paolucci, rowed a primitive manned torpedo called Miniata, Leech, into Polar Harbour and sank the Austro-Hungarian battleship Viribus Unitis. That attack demonstrated both the potential and limitations of the concept. The Miniata was essentially a modified torpedo with a small cockpit, crude controls, and no breathing apparatus for its crew. The operators rode exposed on the weapon's back, breathing through tubes that barely broke the surface. The device could barely make 4 knots and required extraordinary courage to operate. But it sank a battleship, proving that skilled operators with primitive equipment could accomplish what entire fleets could not. 20 years later, Italian engineers returned to this concept with modern technology. The 10th Flottiglia Mass, 10th Light Flotilla, was officially established on March 15, 1941. Though development had proceeded in secrecy since 1936. The unit's headquarters occupied a converted villa in La Spezia, chosen for its proximity to deep water training areas and maximum distance from British reconnaissance aircraft based in Malta. Commander Paolo Aloisi, a decorated submarine officer who had studied British harbour defences during peacetime port visits, assumed command. His mandate was simple and terrifying: develop a weapon system capable of penetrating heavily defended enemy harbours and sinking capital ships at anchor. The technical challenge was formidable. The weapon needed to travel underwater for extended periods to avoid surface detection, carry enough explosive to sink a battleship, operate silently to avoid acoustic detection, withstand water pressure at operational depths up to 50 feet, navigate precisely in complete darkness through mined harbours, and allow its operators to survive the mission and potentially repeat it. That final requirement, operator survival, distinguished Italian development from Japanese kite-and-suicide torpedoes. Italian engineers, designed for repeated missions by experienced operators who would improve with each attack. The investment in training and experience made operator survival a tactical necessity, not humanitarian concern. The resulting weapon, designated SLC, Siluro a Lenta Corsa, represented sophisticated engineering disguised by an unassuming appearance. The device measured 22 feet in length, 21 inches in diameter, and weighed 3,307 pounds fully loaded. The forward section contained the warhead, a detachable charge holding 485 pounds of TNT with magnetic clamps and an adjustable delayed action fuse. The center section housed the electric motor, a 1.6 horsepower unit powered by lead-acid batteries, providing 2.5 hours of operation at maximum speed. The motor drove a single propeller through a simple reduction gear, achieving a maximum speed of 3 knots, approximately walking pace underwater. At this speed, the SLC could cover 15 nautical miles, sufficient to cross most harbours from infiltration points to target anchorages. The control section occupied the rear portion of the device. 2 operators sat astride the torpedo, the forward operator commanding navigation and depth control, while the rear operator managed propulsion and monitored battery status. The control system included a compass mounted in a luminous housing visible in complete darkness, a depth gauge accurate to 1 meter, and rudder controls that required gentle pressure. Aggressive maneuvering could destabilize the device, sending it diving to the bottom or broaching the surface. Both scenarios meant mission failure and likely capture or death. The operators wore full diving suits, custom designed by Italian manufacturers to Italian Navy specifications. The suits used rubberized canvas with sealed seams, neoprene wrists and neck seals, and weighted belts providing neutral buoyancy at operational depths. The breathing apparatus, developed specifically for SLC operations, was a closed-circuit rebreather using compressed oxygen and soda lime to scrub exhaled carbon dioxide. This system produced no bubbles, eliminating the telltale stream that would reveal operators to surface sentries. The rebreather provided 6 hours of operation, though carbon dioxide buildup limited practical mission duration to 4 hours before cognitive impairment became dangerous. Training for SLC operations began in September 1940 at La Spezia's experimental underwater weapons station. The facility occupied a restricted zone surrounded by naval security and Italian army guards with orders to shoot unauthorized visitors on site. Concrete bunkers housed the SLCS between training exercises. A specially modified submarine pen allowed operators to practice infiltration procedures in realistic conditions. Deep water channels beyond the harbour entrance provided navigation training areas where operators learned to maintain course in complete darkness using only compass and elapsed time calculations. The training regime was brutal. Initial candidates, all volunteer submarine personnel, or specialist divers, spent 6 weeks mastering closed-circuit rebreather operation. The equipment was unforgiving. A torn seal or damaged canister meant drowning or asphyxiation within minutes. Operators learned to detect equipment failure by subtle changes in breathing resistance or taste, to perform emergency repairs in darkness while managing panic and preserving oxygen. Of 186 candidates who began training, 47 were eliminated during rebreather qualification when instructors judged them unable to maintain composure during simulated equipment failures. Navigation training consumed another 8 weeks. Operators practiced maintaining precise compass bearings while riding the SLC through underwater obstacle courses. The instructors deployed nets, cables, and artificial barriers, simulating harbour defences. Operators learned to feel obstructions through the SLC's sluggish response to controls, to navigate around obstacles without surfacing, and to maintain situational awareness in conditions of absolute sensory deprivation. The psychological challenge was extraordinary. Riding the SLC in darkness with restricted vision, hearing only one's breathing and the faint hum of the electric motor, operators experienced profound disorientation. The slightest error in depth control could send the weapon plummeting to crush depth or surfacing into searchlight beams. Training records show 23 operators were eliminated for inability to maintain depth control within required tolerances of plus or minus 1 meter. Target approach and mine placement training represented the course's final phase. Operators practiced locating simulated ship hulls in darkness, positioning the detachable warhead against hull curvature, activating magnetic clamps that held the charge in position, and setting delayed action fuses accurate to within 30 seconds across 6-hour delays. The magnetic clamps represented critical engineering. They needed sufficient holding force to resist water currents and ship movement, but had to activate silently to avoid alerting sentries. Italian engineers developed electromagnetic clamps powered by the SLC's batteries, producing 200 pounds of holding force when activated. The fuses used clockwork mechanisms with corrosion-resistant components, tested in saltwater immersion for reliability. Fuse setting required delicate manipulation of small dials in complete darkness while managing breathing apparatus, monitoring oxygen supply, and tracking elapsed mission time. Training records indicate the average operator required 87 practice runs before achieving proficiency in mine placement under simulated combat conditions. The first operational mission, Operation BG-1, launched on August 26, 1940, targeting British warships in Alexandria Harbour. 4 SLCs departed La Spezia aboard the submarine Iride for transport to launch positions outside Alexandria. British aircraft spotted and sank Iride before the SLCs could launch, killing all 8 operators and destroying the weapons. The disaster forced Italian planners to reconsider infiltration methods. Surface transport was clearly impossible. Submarine delivery to positions immediately outside target harbours was required, but standard submarines lacked facilities to launch SLCs while submerged. The engineering solution was elegant. Italian engineers converted 3 submarines, Scire, Gonda, and Ambra, by welding cylindrical containers to their hulls. Each container, 20 feet long and 7 feet in diameter, could hold 1 SLC in a flooded compartment, accessible from inside the submarine through a pressure hatch. Operators could enter the container while submerged, flood it to equalize pressure, open exterior hatches, and ride the SLC clear of the submarine without surfacing. The modified submarines began operations in September 1941. Scire, commanded by Lieutenant Commander Junio Valerio Borghese, a nobleman whose family had served Italian naval forces since the 16th century, transported SLCS for the next series of attacks. Borghese was not merely a submarine commander, but an operations planner who understood that successful SLC attacks required coordinating submarine infiltration with SLC navigation and enemy patrol patterns. His operational plans specified exact launch positions calculated from harbour charts current patterns measured during peacetime visits, and expected patrol schedules derived from signals intelligence, Operation BG-2, launched September 20, 1941, targeted Gibraltar with 3 SLCs transported by Skyre. The operators, Lieutenant Antonio Marseglia with Petty Officer Spartaco Shergat, Captain's Mate Vincenzo Martellotta with Diver Mario Marino, and Sub-Lieutenant Amadeo Vesco with Diver Luigi Stara, launched from positions 3 miles outside Gibraltar's harbour entrance. They navigated through the defensive boom at 2:30 a.m. on September 21st, following a British patrol boat through the temporarily opened gate. Inside the harbour, they separated toward assigned targets. Marseglia and Shergat located the tanker Dembydale, 8,145 tons, and placed their charge beneath the engine room. Martellotta and Marino found the cargo ship Durham, 10,893 tons, and secured their warhead amidships. Vesco and Stara encountered navigation problems, surfaced briefly to verify position, and were spotted by sentries. They abandoned their SLC and scuttled it to prevent capture before swimming towards Spanish territory. The charges exploded at 5:30 a.m. with devastating effect. Dembydale's back broke, the ship settling in 2 sections that blocked harbour approaches for 6 weeks. Durham sank in 20 minutes, her hull ripped open across 40 feet. The explosions occurred simultaneously, preventing damage control parties from responding to both ships. British investigators initially suspected aerial bombardment or submarine attack, not believing that divers could penetrate Gibraltar's defences. Only when Spanish authorities captured Vesco and Stara and discovered their specialised equipment did British intelligence begin understanding Italian capabilities. The captured operators, following pre-mission instructions, claimed they were training casualties swept off course by currents. British interrogators, lacking knowledge of SLC operations, could not effectively question them. The success at Gibraltar validated Italian tactics and emboldened planners to attempt the ultimate target, Alexandria Harbour, where Britain's Mediterranean fleet anchored between operations. Alexandria presented challenges exceeding Gibraltar's difficulties. The harbour entrance was protected by multiple defensive booms, acoustic detection equipment, depth charge stations, and continuous destroyer patrols. British battleships anchored in the inner harbour, requiring SLC operators to navigate through 3 defensive zones across 4 miles of patrolled water. Yet Alexandria was the decisive target. Sinking or damaging British battleships would shift Mediterranean naval balance, enabling Italian convoys to reach North Africa without facing overwhelming British firepower. Borghese commanded Skyre on the Alexandria mission, designated Operation EA-3 with 6 operators, Lieutenant Della Penna with Diver Bianchi, Captain Antonio Marseglia with Diver Spartaco Shergat, and Captain Vincenzo Martellotta with Diver Mario Marino. The operators were the service's most experienced, with 400 to 600 training hours each. Della Penna, 29 years old, had survived 2 previous missions including Gibraltar. His psychological profile noted exceptional composure under stress and ability to maintain navigational precision during equipment malfunctions. Marseglia, 28, was considered the unit's best technical operator, capable of diagnosing and repairing mechanical failures while submerged. Martellotta, 27, specialized in rapid mine placement, holding training records for attachment time. Skyre departed La Spezia on December 3, 1941, carrying 3 SLCs in hull containers and supplies for extended patrol. The submarine navigated to positions outside Alexandria, remaining submerged during daylight to avoid British air patrols based at Almeria Airfield. British signals intelligence detected increased Italian submarine activity, but attributed it to convoy interdiction efforts. No intelligence suggested attacks on anchored capital ships were planned or possible. This intelligence failure reflected institutional blindness to unconventional threats. British naval doctrine focused on fleet-to-fleet engagement and submarine torpedo attacks, not imagining that divers would ride primitive torpedoes through defended harbours to plant mines by hand. On December 18th, Borghese positioned Skirre 1.3 nautical miles from Alexandria's harbour entrance in 60 feet of water. British destroyers patrolled overhead, their propellers audible through Skirre's hull as they passed. At 6:42 p.m., Borghese gave launch orders. The operators entered the pressure chambers, flooded them, and opened exterior hatches. The SLCS started smoothly, their electric motors barely audible even to operators sitting astride them. The three weapons separated, each navigating independent courses toward assigned targets inside the harbour. De la Penne commanded SLC 221, targeting HMS Queen Elizabeth. Marseglia commanded SLC 222, assigned to HMS Valiant. Martellotta commanded SLC 223, with the tanker Sagona as primary target and destroyer HMS Jervis as alternate. The journey from launch position to harbour entrance required 2 hours of precise navigation. The operators maintained depth at 15 feet, deep enough to avoid visual detection, but shallow enough for compass readings. Surface currents running at 1.2 knots required constant correction to maintain course. The SLCs crossed the first defensive boom at 8:30 p.m., following standard procedure of waiting for patrol boats to pass, then crossing during the gap in coverage. No alarms sounded. The defensive boom was designed to stop submarines, not detect small, slow-moving objects near the surface. Inside the outer harbour, the operators navigated through commercial shipping traffic toward the inner harbour where capital ships anchored. De la Penne's SLC suffered mechanical problems at 9:15 p.m. when the depth control mechanism jammed. The weapon began diving toward the bottom. De la Penne manually controlled depth using the motor for 45 minutes while attempting repairs. He managed to regain control but lost significant battery power, reducing his operational time. He pressed forward, knowing that aborting would waste months of planning and sacrifice 2 previous missions' intelligence gathered at great cost. The inner harbour boom presented the greatest obstacle. British engineers had installed anti-submarine nets extending 40 feet below the surface, with acoustic sensors designed to detect metal contact. The gates opened periodically to allow patrol boats to enter and exit. The timing was irregular to prevent enemy exploitation. De la Penne waited in darkness 300 yards from the boom, watching the silhouettes of destroyers above him. At 11:40 p.m., a patrol boat signaled the gate open. De la Penne accelerated the SLC to maximum speed, following the patrol boat through the gap. Marseglia and Martellotta followed at 30-second intervals. The boom closed behind them. They were inside Alexandria's inner harbour with no retreat path. De la Penne located HMS Queen Elizabeth at 1:30 a.m., her distinctive superstructure silhouetted against harbour lights. He approached from the stern quarter, maintaining depth at 12 feet to pass beneath anti-torpedo nets that protected the battleship's sides. At 2:20 a.m., he positioned the SLC beneath Queen Elizabeth's hull, directly below the forward magazine. This location was not random. Italian intelligence had acquired detailed plans of Queen Elizabeth-class battleships, identifying the forward magazine as the optimal location for maximum damage. An explosion here would detonate stored shells, destroying the ship through internal blast, rather than hull breaching alone. De la Penne's breathing apparatus was nearing its operational limit. Carbon dioxide buildup caused headache and disorientation. He had approximately 45 minutes of safe breathing time remaining. He and Bianchi began the mine placement procedure they had practiced hundreds of times. They released the warhead from the SLC, positioned it against the hull curvature, activated the magnetic clamps, and verified attachment. The clamps engaged with a subtle click audible through the water. No alarm sounded above. They set the delayed action fuse for 6:10 a.m., providing 3 hours and 50 minutes for infiltration and escape. The fuse mechanism clicked as it engaged. Bianchi gave the thumbs-up signal. The charge was active. At 2:47 a.m., De La Penne and Bianchi began their withdrawal. They rowed the SLC toward the harbour entrance, hoping to clear defensive booms before oxygen depletion forced them to surface. But the earlier mechanical problems had consumed critical battery power. At 3:15 a.m., the SLC's motor stopped, batteries exhausted. They were 1.2 miles from the harbour entrance with no propulsion and failing breathing apparatus. De La Penne made the decision to surface, scuttle the SLC, and attempt swimming to shore. They surfaced at 3:22 a.m., removed their breathing apparatus, and gasped fresh air. Within minutes, searchlights found them. A patrol boat approached, machine guns trained on the swimmers. De La Penne raised his hands in surrender. The war for him had ended, or so British guards believed. Marseglia and Shergat encountered fewer problems. They located HMS Valiant, Queen Elizabeth's sister ship, at 2:50 a.m. and positioned their charge beneath the forward magazine using the same placement technique. They set their fuse for 6:10 a.m., synchronized with De La Penne's charge, though neither team knew the other's status. They successfully withdrew from the harbour, clearing the outer boom at 4:20 a.m. before their oxygen supply became critical. They beached the SLC on a remote shoreline, buried their equipment, and walked toward Italian lines disguised in civilian clothing, stolen from a harbour warehouse. Italian intelligence met them at pre-arranged locations, and they reached Italian territory on December 24th, 6 days after the attack. Martellotta and Marino targeted the tanker Sagona, but discovered she had departed Alexandria the previous day. They adapted, locating HMS Jervis, a J-class destroyer displacing 1,690 tons. While smaller than their primary target, Jervis represented a valuable kill. British destroyers were critical for convoy escort and submarine hunting. They placed their charge beneath Jervis's engine room at 3:05 a.m. and set the fuse for 6:10 a.m. They successfully withdrew, following Marseglia's path to shore and eventual return to Italian lines. De La Penne and Bianchi were taken aboard HMS Queen Elizabeth for interrogation. Lieutenant Douglas Campbell, the ship's intelligence officer, questioned them repeatedly about their mission and equipment. De La Penne, following pre-mission protocols, identified himself by rank and name but refused further information. Campbell suspected sabotage but lacked understanding of SLC capabilities. He could not conceive that these two divers had planted enough explosive to sink his ship. At 5:45 a.m., Campbell terminated interrogation and ordered the prisoners confined in the forward hold, directly above the magazine where De La Penne had placed his charge. De La Penne checked his waterproof watch. 5:47 a.m. He had 23 minutes before detonation. The explosion would kill everyone in the forward section, including the prisoners. Italian planning had not anticipated capture before detonation. De La Penne faced a moral calculation. He could remain silent, allowing the attack to succeed while dying with British sailors who were simply following orders. Or he could warn his captors, saving lives, but potentially allowing them to disarm the charge and negate months of preparation. At 6:05 a.m., De La Penne requested to speak with the ship's captain. Commander Charles Morgan arrived at 6:08 a.m., 2 minutes before scheduled detonation. De La Penne stated, "In 5 minutes, your ship will explode. I suggest you evacuate the forward section immediately." Morgan, stunned, ordered general quarters. Damage control parties rushed to battle stations. Sailors evacuated forward compartments. Morgan demanded the charge's location. De La Penne refused to specify, maintaining his duty to complete the mission while satisfying his conscience about the prisoners. At 6:10 a.m., the charge detonated. The explosion lifted Queen Elizabeth's bow 10 feet out of the water before the battleship crashed down, her forward hull split open across 40 feet. Water flooded into the forward magazines, But the shells did not detonate, having been wetted before the heat could trigger them. The ship began settling by the bow. Morgan ordered counterflooding to maintain level trim, but Queen Elizabeth continued settling until her keel rested on the harbour bottom in 40 feet of water. Her superstructure remained above water, creating the appearance that she was still operational. British photographers carefully documented the ship from angles that concealed the settling, maintaining the illusion that Queen Elizabeth remained combat-ready. At 6:12 a.m., HMS Valiant exploded, Marsalia's charge detonating beneath her forward magazine. The blast was larger than Queen Elizabeth's, the TNT charge having been positioned in a more confined space that focused the explosion's force. Valiant's forward hull section tore away completely. She settled to the bottom faster than Queen Elizabeth, her superstructure tilting at a 5-degree list. Again, British damage control teams maintained appearances, carefully positioning Valiant to hide the extent of damage from aerial reconnaissance. At 6:14 a.m., HMS Jervis exploded, Martelotta's charge destroying her engine room. The destroyer's back broke, and she sank in 12 minutes. Unlike the battleships resting in shallow water, Jervis went to the bottom completely, her superstructure disappearing beneath the surface. There was no concealing this loss. The 3 explosions, within 4 minutes, created chaos in Alexandria Harbour. Air raid sirens wailed, anti-aircraft batteries opened fire on non-existent aircraft, destroyers departed at flank speed, searching for submarines that had already escaped. Admiral Andrew Cunningham, commanding the Mediterranean fleet from ashore, rushed to the harbour. He observed Queen Elizabeth and Valiant apparently floating normally, and initially believed they had escaped serious damage. Only when diving inspections revealed the truth did he understand the catastrophe. British signal intelligence intercepted and decoded Italian naval communications within hours. The intercepts confirmed that Italian SLC operations had conducted the attack. Cunningham ordered strict censorship. All personnel with knowledge of the true damage were confined to base. Photographers received instructions to document ships only from angles concealing their settled positions. British Information Ministry released carefully worded statements acknowledging explosions but denying serious damage. Newspapers published photographs showing Queen Elizabeth and Valiant apparently operational, their settling hidden by camera angles. The deception succeeded for weeks. German and Italian reconnaissance aircraft photographed Alexandria repeatedly, but the images showed British battleships apparently ready for sea. Axis intelligence concluded the attacks had caused minor damage, perhaps flooding some compartments, but not eliminating the battleships from operational status. This intelligence failure had strategic consequences. German planners did not revise their Mediterranean strategy to exploit British naval weakness. Italian convoys continued facing restrictions based on assumed British strength that no longer existed. The reality was devastating. HMS Queen Elizabeth required 7 months of repairs, not returning to service until September 1942. HMS Valiant needed 9 months, becoming operational in November 1942. HMS Jervis was a total loss. During these months, Britain had no operational battleships in the Mediterranean. Aircraft carriers and cruisers maintained presence, but without battleship support, they could not engage Italian heavy units on equal terms. The strategic balance had shifted precisely as Italian planners intended. The human cost was remarkably low. Della Penna's warning allowed Queen Elizabeth's crew to evacuate the forward section. 4 sailors died in the explosion, killed by the blast wave before they could escape. Valiant's explosion killed 6, caught in compartments that flooded instantly. Jervis lost 19 when the ship sank quickly. Total British casualties, 29 dead and 47 wounded, were extraordinarily light, considering that 3 capital ships had been sunk or crippled. This reflected both Italian planning that targeted material rather than personnel and British damage control proficiency that minimised flooding casualties. Italian casualties were 0 on the operational side. All 6 operators survived. Della Penne and Bianchi spent the remainder of the war in British prisoner-of-war camps. Marseglia, Scergat, Martellotta and Marino returned to La Spezia as heroes. They received Italy's highest military decoration, the Medaglia d'Oro al Valor Militare, Gold Medal of Military Valor. Della Penne received his medal in 1943 from British Admiral Morgan in a ceremony conducted in the prison camp, Morgan acknowledging courage and professionalism even in enemy operators. The Alexandria attack's success prompted examination of British harbour security throughout the Mediterranean. Every port underwent defensive upgrades. Boom defences were strengthened with additional nets extending deeper. Acoustic sensors were recalibrated to detect smaller targets. Continuous depth charge patterns were established to deter submerged approach. Underwater illumination was installed at critical anchorages. The improvements were substantial, but they could not be completed instantly. Italian SLC operations continued exploiting gaps in coverage. July 25, 1942, 3 SLCs launched from submarine Ambra attacked Malta's Grand Harbour. British defences detected and destroyed 2 SLCS before they reached attack positions. The third, commanded by Lieutenant Roberto Frassetto, penetrated the inner harbour and attached his charge to the cruiser HMS Kenya. The explosion at 3:40 a.m. damaged Kenya's propulsion system, requiring 3 months of repairs. The attack demonstrated that even improved defences could not guarantee security against determined operators. August 10, 1942, submarine Sirè attempted another Malta attack. British signals intelligence had decoded Italian operational messages, providing warning of the attack. Destroyers saturated Sirè's approach path with depth charges. The submarine was detected and sunk with all hands, including Commander Borghese, who had transferred to shore duty the previous month. His replacement, Lieutenant Gustavo Stefanini, died with 48 crew. The loss of Skyray eliminated Italy's most experienced SLC transport submarine and severely limited future operations. Despite losing Sirè, Italian SLC operations continued through 1943. Modified submarines conducted smaller-scale attacks against British shipping at Gibraltar and Port Said. The success rate declined as British defences improved and Italian logistics deteriorated under Allied bombing. The final SLC attack occurred on August 3, 1943, at Gibraltar. 2 SLCs damaged merchant ships totaling 14,000 tons before British destroyers sank the transport submarine during withdrawal. Italian armistice negotiations were already underway, and the operation was effectively meaningless. The strategic impact of SLC operations exceeded their modest scale. Between September 1941 and August 1943, Italian operators sank or damaged 2 battleships, 1 cruiser, 1 destroyer, and 12 merchant ships totaling approximately 78,000 tons. This represented more British Mediterranean fleet tonnage than Italian surface fleet actions achieved during the entire war. The cost was extraordinarily low. Italy lost 2 transport submarines and 52 submariners, 4 SLC operators killed in action, and 6 captured. Material costs were minimal, perhaps 3 million lira for the entire SLC program, including training facilities, equipment production, and operational support. The operational statistics reveal remarkable efficiency. Italian SLC operators conducted 14 major attack missions penetrating defended harbours. 8 missions succeeded in placing charges that detonated. 6 missions failed due to mechanical problems, enemy detection, or navigational errors. Success rate, 57%. When charges detonated, they achieved desired effect, major damage, or total loss. Not a single charge failed to detonate or produced insufficient damage. This 100% effectiveness rate once the weapon was employed demonstrates the engineering quality and training proficiency of Italian operators. The psychological impact on British forces exceeded the material damage. Every British-controlled harbour in the Mediterranean required expensive defensive upgrades. Patrol requirements increased, diverting destroyers from convoy escort duties. Acoustic detection equipment was installed at ports across 3 continents. Underwater barriers were constructed using scarce steel and concrete. Thousands of personnel were assigned to harbour security, reducing forces available for offensive operations. The mere possibility of SLC attack forced defensive preparations that consumed resources, far exceeding Italy's actual SLC capabilities. British intelligence eventually captured intact SLC equipment and interrogated operators. Technical analysis revealed Italian engineering sophistication. The SLC represented optimal design compromise between performance requirements and operational constraints. British engineers recognized that given the same requirements, they would have produced remarkably similar weapons. This professional acknowledgement was unusual, considering British engineering's reputation for superiority. Post-war analysis concluded that Italian SLC operations represented near-perfect execution of unconventional naval warfare, achieving strategic effects through tactical innovation rather than material superiority. The SLC concept influenced special operations development across multiple nations. British combined operations examined captured SLC equipment and developed X-craft midget submarines for similar harbour penetration missions. German Kriegsmarine developed Neger and Marder human-guided torpedoes, though these were suicide weapons, lacking the SLC's operator survival capability. American Office of Strategic Services studied Italian methods when developing underwater demolition teams for Pacific operations. Japanese Navy developed Kaiten torpedoes, but these were pure suicide weapons without the sophisticated controls or detachable warheads that characterized Italian design. The British X-craft program demonstrated direct SLC influence. X-craft were larger than SLCs, displacing 30 tons versus 3.3 tons, and carried crews of 4 rather than 2. But the operational concept, penetrating harbours to attach charges to anchored ships, was identical. British X-craft attacks on German battleship Tirpitz in September 1943 used tactics pioneered by Italian SLC operators. The success of these attacks, damaging Tirpitz sufficiently to eliminate her as an operational threat, validated Italian methodology. American underwater demolition teams developed for Pacific operations incorporated lessons from captured SLC documentation. While American frogmen primarily conducted beach reconnaissance and obstacle clearance rather than ship attacks, the training methodologies, rebreather technology, and approach procedures directly descended from Italian innovation. Post-war American combat swimmer programs acknowledged Italian precedent in their doctrinal publications. Soviet naval forces captured Italian SLC operators who had been transferred to German custody after Italy's 1943 surrender. These operators were extensively interrogated about equipment and tactics. Soviet naval infantry developed combat swimmer programs using information extracted from Italian prisoners. The similarity between post-war Soviet combat swimmer equipment and Italian SLC technology suggests direct technology transfer, though Soviet documentation remains partially classified. The recognition of Italian SLC achievements transcended wartime enmity. Winston Churchill wrote in his post-war memoirs, "The Italian Navy's achievement with human torpedoes demonstrated courage and technical proficiency worthy of the highest praise." These men conducted the most devastating harbour penetration attacks of the entire war, crippling British naval power at a critical moment. Their success reflected both individual bravery and systematic preparation. This acknowledgement from Britain's wartime leader, who rarely praised enemy capabilities, indicated the profound impression Italian operations made on British military leadership. Admiral Cunningham, whose Mediterranean fleet was crippled by SLC attacks, provided similar assessment in his memoir, A Sailor's Odyssey, published in 1951. The Italian underwater operators displayed extraordinary courage and professional skill. Their attacks on Alexandria represented naval warfare's most daring innovation. We were fortunate that Italian material limitations prevented them from conducting more such operations. Cunningham's admission that British defences were inadequate to stop determined SLC operators reflected professional respect that transcended national rivalry. Individual British officers who encountered Italian SLC operators maintained correspondence with them after the war. Admiral Morgan, who commanded HMS Queen Elizabeth when De La Penne's charge exploded beneath her, wrote to De La Penne in 1947, "Your conduct during and after the attack exemplified military professionalism. You completed your mission, took measures to minimize casualties, and maintained dignity in captivity. It was my honor to present your medal, even under those circumstances." This personal acknowledgement from the officer whose ship was sunk demonstrated that professional military communities recognized excellence regardless of nationality. Post-war Italian naval forces maintained the SLC tradition through the Gruppo Operativo Subacquei, Underwater Operations Group, later redesignated COMSUBIN, Comando Raggruppamento Subacquei ed Incursori Teseo Tesei. The unit preserved SLC equipment, training facilities, and operational doctrine. Modern Italian combat swimmers train at the same La Spezia facilities, where SLC operators prepared for Alexandria. The institutional continuity spanning 8 decades represents recognition that the SLC program achieved something historically significant. The technical legacy extended beyond military applications. Italian commercial diving companies employed former SLC operators after the war, utilizing their specialized skills for underwater salvage, construction, and inspection. The closed-circuit rebreather technology developed for SLC operations formed the foundation for modern technical diving equipment. Contemporary commercial and recreational rebreathers use principles engineered by Italian naval technicians, solving the problem of silent underwater breathing in the late 1930s. The strategic lessons remained relevant decades after the operations. Military planners examining asymmetric warfare consistently reference Italian SLC operations as demonstrating how small forces with specialized capabilities can achieve effects disproportionate to their size. The concept of using highly trained operators with precision equipment to attack high-value targets in defended locations became foundational to special operations doctrine. Modern special forces conducting harbour penetration operations employ methodologies directly descended from Italian innovation. The forgotten heroes of SLC operations were not the operators who received medals and recognition, but the engineers and technicians who created the systems. Men like engineer Captain Teseo Tesei, who developed the SLC's control systems and died testing improved equipment at Malta in 1941, never received public recognition. His name appears on the unit's modern designation, but few outside Italian naval circles know his contribution. Similarly, the civilian engineers at Società Italiana Ernesto Breda, who manufactured SLC components, worked under conditions of complete secrecy, their achievement unrecognized beyond classified naval records. The mechanics and support personnel who maintained SLC equipment at La Spezia faced similar obscurity. These men prepared the weapons, tested batteries, inspected rebreathers, and verified every system before operators departed on missions. Their competence was essential to operational success, yet their names appear nowhere in historical accounts. A single mechanical failure, one corroded seal or improperly charged battery, could kill operators and negate months of planning. That no SLC ever failed due to mechanical problems during critical mission phases reflected maintenance personnel's professionalism and dedication to detail. The submarine crews who transported SLCS into enemy waters risked their lives repeatedly. Skyray conducted 10 infiltration missions before her loss, each time penetrating defended waters and remaining submerged for hours, while SLC operators prepared for launch. Submarine crews understood that British depth charges could destroy them at any moment, yet they maintained position until operations completed. Their courage was equal to the operators, though they received far less recognition. The final accounting of Italian SLC operations reveals a remarkable achievement. With primitive technology by modern standards, minimal financial investment, and small personnel numbers, Italian naval forces temporarily crippled British Mediterranean naval power, shifted the strategic balance for 9 months, influenced special operations development across multiple nations, and demonstrated that innovation and training could overcome material disadvantage. These lessons remained relevant 8 decades later, studied by military professionals examining how small forces achieve disproportionate effects. The story began with Lieutenant de la Penne beneath HMS Queen Elizabeth in the darkness of Alexandria Harbour. It ended with recognition that his courage and professionalism, multiplied across a small community of Italian operators, had achieved something historically significant. They did not win Italy's war. Industrial and strategic realities guaranteed eventual defeat, regardless of tactical successes. But they demonstrated that unconventional thinking, combined with technical excellence and extraordinary courage, could accomplish what conventional forces could not. That lesson transcended the specific circumstances of their operations and resonated across subsequent generations of special operations forces. The human torpedoes that crippled the British Mediterranean fleet were not miracle weapons or technological marvels. They were carefully engineered solutions to specific operational problems, operated by extensively trained personnel who understood both their capabilities and limitations. The success reflected systematic preparation rather than desperate improvisation, professional execution rather than reckless courage. These operators were not suicide attackers, but skilled technicians conducting precision missions with the expectation of survival and repetition. This professional approach, more than any technical characteristic, explained their success and ensured their lasting influence on military operations. In museums across Italy, preserved SLC torpedoes rest in climate-controlled displays. The devices look almost pathetic to modern eyes, crude metal tubes with simple controls and exposed batteries. Visitors struggle to imagine that anyone would ride such primitive equipment through enemy harbours into combat. But the operators who climbed aboard these weapons in December 1941 were not desperate or suicidal. They were professionals executing a carefully planned operation, using equipment they understood thoroughly. Their achievement was not overcoming fear, though fear was certainly present, but maintaining professional focus and technical precision under conditions designed to destroy both. The legacy endures not in museums or monuments, but in the ongoing operations of special forces worldwide conducting harbour penetration, ship attacks, and underwater sabotage using methodologies pioneered by Italian SLC operators. Every modern combat swimmer who rides a delivery vehicle through defended waters toward a high-value target follows the path first taken by de la Penne, Marseglia, and Martellotta. The technology has evolved, but the fundamental concept remains unchanged. Skilled operators using specialized equipment to achieve effects that conventional forces cannot. That concept, proven in Alexandria Harbour on December 19, 1941, shaped special operations warfare for the following 8 decades and will likely continue shaping it for decades to come. The men who rode slow-running torpedoes through enemy harbours understood they were attempting something unprecedented. They could not know their operations would cripple the Mediterranean fleet, shift strategic balance, and influence special operations development worldwide. They knew only that they had trained extensively, their equipment was sound, and their mission was achievable if they maintained professional discipline. That combination of preparation, capability, and focus enabled 12 Italian naval officers and enlisted men to sink more British tonnage than entire fleets and bomb wings accomplished. Their achievement was not triumph over material reality. The industrial and strategic factors that determined the war's outcome remained unchanged, but demonstration that human factors, training, courage, innovation, could temporarily overcome material disadvantage and achieve objectives that conventional wisdom considered impossible. That lesson, perhaps more than any specific tactical or technical innovation, represents Italian SLC operations' enduring legacy. The slow-running torpedoes are obsolete. The specific harbour penetration techniques have been superseded by improved technology. But the principle that small numbers of highly trained operators with appropriate equipment can achieve effects disproportionate to their size remains foundational to special operations doctrine. Every time special forces conduct unconventional operations against high-value targets in defended locations, they validate the methodology pioneered by Italian combat swimmers in World War II. The forgotten heroes are not the decorated operators whose names appear in history books, but the hundreds of personnel who supported operations, the engineers who designed equipment, mechanics who maintained it, submariners who transported it, intelligence officers who planned operations, and training instructors who prepared operators. These men worked in obscurity, their contributions known only within classified naval circles. Without them, the operators could not have succeeded regardless of their courage or skill. Recognition of their achievement requires acknowledging that successful military operations depend on systematic preparation, institutional support, and collective effort, rather than individual heroism alone. The slow-running torpedoes that attacked Alexandria Harbour in December 1941 represented one small element of World War II's vast machinery. They did not alter the war's outcome. Industrial capacity, strategic geography, and numerical superiority determined victory. But within their limited scope, Italian SLC operations achieved near-perfect execution of unconventional warfare, combining innovation, training, courage, and technical excellence to produce effects that exceeded all reasonable expectations. That achievement, analysed and studied across subsequent decades, influenced special operations development worldwide and established principles that remain valid in contemporary military operations. The men who accomplished it deserve recognition not as desperate warriors conducting suicide missions, but as skilled professionals executing carefully planned operations with remarkable success. Their story is not about triumph over impossible odds, but about what thorough preparation, appropriate equipment, and professional execution can achieve even when facing material disadvantage. That lesson remains relevant wherever military forces confront situations requiring unconventional solutions to conventional problems.